There are 2 point charges located 0.8 meters away from each other. That means from the center of this one to the center of this one over here, there is 0.8 meters distance. Which of the 2 charges has excess electrons on it? We look and say, well, this one has a negative charge, this one has a positive charge. So the negative 5 microcoulomb charge has excess electrons on it, meaning there's more electrons on this sphere than there are protons. But how many extra electrons? I can take the 5.0 times 10 to the minus 6, and that would be coulombs. We can multiply that by 6.25 times 10 to the 18th electrons per 1 coulomb. And of course, the coulombs will cross off, and we're left with electrons. That will equal 3.1 times 10 to the 13th extra electrons on that sphere. So that's how we can figure out, because 1 coulomb is equal to this value of electrons. Now, what about the magnitude of the force electric acting on the positive 2 microcoulomb charge? Well, and then we'll also look at the direction in a minute. So force electric, then we equal 9 times 10 to the 9, multiplied by 5 times 10 to the minus 6. Remember, we don't put negatives in there. Multiplied by 2 times 10 to the minus 6. Okay, divided by the distance between them squared. So 0.80 squared. So the force electric acting on the 2 microcoulomb charge is equal to 0.14 newtons. Now, what about the direction of that force? Well, we always look at the charges. This is a negative charge, this is a positive charge. That means they are attracted to each other. So this charge here is going to be pulled in this direction towards the yellow charge. So we can identify the direction as left or west. Always look at whether the charges are attracted to each other or repelled to determine that direction. Now, what if we attach a wire across these two, a metal conducting wire across the two? The electrons are going to flow from our negative charge over to our positive charge. We need to recalculate the charge on each one. So they'll just average out. So I'm going to say Q is going to equal negative 5 microcoulombs plus 2 and divided by 2. Well, negative 5 plus 2 is a negative 3, and then divide that by 2. The new charges on both is going to be negative 1.5 microcoulombs. And we want to calculate the electric force now existing between both charges once the metal conducting wire has been put across them. So I'll just do force electric equals 9 times 10 to the 9 multiplied by 1.5 times 10 to the minus 6. Notice again, I'm not writing the negative in there. Multiplied by 1.5 times 10 to the minus 6 divided by 0.80 squared again. And our new force electric is equal to 0.032 newtons.